Hey guys, it's Bill from Linden, Tennessee. So progress continues. Actually, you see I got some new wheels, a little beefier wheels. They have kind of a different offset. So the inside between wheels is about 1.25 inches more than it is in the front. I can fix that if I wanted to by putting some spacers on those front wheels, just to space them out a little bit. But I'll wait till I get the tires on the wheels and just see how it kind of looks. I need to find someone who has a sandblaster, and I got to figure out how I'm going to paint these things. Might paint them, could powder coat them. I don't know. Probably going to powder coat them because that'd be much more durable, and it'd look nice too. Anyway, yeah. So the motor. So this was kind of a fun little challenge to get going. Yeah. So I kind of had an idea of where the bottom gear was going to be. Actually, I knew where it was going to be. It was basically slid back as far as it can go, and sort of locked in place. These are kind of neat little deals. They got these 3 little screws, and what happens is this is a 2-piece part, and there's a wedge. This has got a wedge, and this is the opposite of it. So whenever you tighten these nuts down, these bolts down, it pulls this gear into or over the top of this wedge, and it pinches that together really tight, and there's a cotter key in there. But yeah, it's just really solid mount. And then to get these things undone, you take these 3 out and you put them in here where the bolt is threaded right here, and then as you tighten it in, it pushes on this gear away to release it from that tension. So it's a very positive, pretty neat little dude, or a neat little way of doing it. So anyway, so yeah, so I knew where that one was going to be. Then I just kind of put this one on here, sort of at the end of the motor shaft there, and got myself a straight edge, and used some pieces of wood and some cardboard, and had it all up underneath of here, so the motor was supported by all that stuff. Tried to get the motor as level as I could, and straight and parallel and everything, and then I just put a straight edge against this face right here, and then extended it down that way, and basically just looked for a gap, looked for an air gap, and I wanted the air gap on this side and the air gap on that side to be the same. I wasn't too concerned about getting rid of that air gap completely, because this belt does have some play in it, and if nothing else, I could always move this pulley one way or the other, the small amount that the gap is there. I mean, we're talking a 1/16 of an inch or less. So I got the gap as close to both sides as I could, and that was it. So once I had it there, then I could just put a couple tacks on the side there, and I made these little triangle supports and tacked them in, and then I was able to move all my what do they call it? There's a word down here in the South, they call it scotch. They call it scotching. So like, if I don't know where that comes from, but it's definitely not something. I'm from Missouri. I'm not originally from Tennessee, but scotching is so like if you have a truck, say and it doesn't have a good emergency brake, good parking brake, then you would want to scotch one of the wheels so that it doesn't roll down a hill into a ditch and run into a tree. That's the ideal, what you would want to do by scotching something. Anyway, sorry, I digress. Yeah, so that's it. So that's the motor. That's where that's going to go. Eventually I'll kind of mark this where that goes and just sort of cut that off so that it looks nice, so that thing's not sitting out there crazy. So the belt is as tight as I could get it, but still be able to remove it. So it's kind of hard to get that off of there, which is kind of what I wanted. I wanted this as tight as I could. Now I could have done this a couple different ways to get this tension. I could have slotted, or could have mounted some brackets here with slots in it and some sort of an adjuster screw. I could have put this whole motor on like a pivot, so it would have sort of come up and put tension on this belt. But what I'm going to end up doing is I'm just going to get a pulley, just something about, I don't know about that big, and it'll just push into the non-driven side. Now technically it's both sides are driven, because if I go in reverse, then this side will be driven, but I won't go in reverse near as much as I'll go forward. So this is technically the non-driven side, so I'll have this wheel pushed in there, and then probably have some sort of an adjuster screw going through here that acts on that somehow. I'm not really sure how I'll do that yet, but that's not a really big deal. So that's what I'll do there. And as for the drive shaft, yeah, there it is. Made these little 1/8 inch brackets. I got them cut out on the bottom, you see down there, because whenever you do stuff like this, you need to think ahead. You got to think, if I ever need to service any of this stuff, how am I going to get this out of here? Now, I could have easily just put this plate on there, you know, taken this shaft off, put the plate on, put the bearing on, all that stuff all at one time, welded it all in there, but I'd never get it apart again. I'd have to cut the thing apart. So I kept that off down there. So if I ever need to remove any of this stuff, then all I got to do is, you know, loosen these nuts, loosen these set screws, and then, you know, the shaft can come out. And the way this kind of works is, ooh, actually, I may have just messed myself up. I'm glad we had this talk. So the way this shaft goes on there, this part slides back and it slides onto those splines. And then the way I have it designed is that this part of the U-joint slides back on this shaft. So it slides back further on this shaft. And that's how you get this drive shaft out. So at the moment, how I have this welded in there now, I wouldn't be able to get this drive shaft off. I don't think. Actually, let's try it. Let's do it. Let's do it since we're all here. Why is it that Allen wrenches get magnetized? I don't understand. Allen wrenches get magnetized. So the way this works is you come up here, you undo that one, and you undo that one. Like that, and then you come undo this one. I'm trying to hold the camera and look, so. And then you come up there and do that one, undo that one. Yeah, so that's the way up. And then what you do is you slide that forward, and then ideally, if that wasn't there, I could slide this U-joint further, and then that would get me the room I need to get this drive shaft off. But I messed that up, so I'm gonna have to fix that. I'll have to undo these tack welds and fix it. So that's okay. That's not hard. It's going to be kind of hard to get in there to get them tack welds out. I don't know how I'm going to do that. Dremel tool and a little cutoff wheel. Yep. Because I just did little bitty tack, so it's no big deal. Yeah. So got to fix that. And then up here with this one, if I ever need to get this mess off, getting this gear off is actually the problem. So the way to get these out, if you loosen these right now, they won't actually go. Like the bolt is too long, it'll hit this. But what you can do is you can rotate this around, and then where it's cut out down there, that gives you enough room to get that bolt out, and then you can put it back, and you can put it in this threaded part and press that off or whatever. But you'd get this drive shaft off. You take this drive shaft off, and then you take this bearing off, and then you could have full access to it. Yeah, so that's no big deal there. Let's see, what else? Oh, so my pivot is going to be the next thing. Kind of tossing up some ideas, not really exactly sure how I'm going to do that. So one of the ideas that I had was this big dude right here. So this is just a 5/8 inch hole in a 3/4 inch chunk of steel. I thought I could like weld that to the bottom, and then this part could just stick out, and I don't know how that was going to work. Yeah, I do. And this part would just sort of stick out and kind of go into that. So sort of screw into that. Now I need to make this bigger. That's too thin. That's not going to work. But that's one way of doing it. So that's how it would look underneath the machine, kind of like that. Another way I thought about I could do it is, I rejected this idea because it'd just be too bulky. This could weld up to the bottom like this, and then this part would go in here like that, and then I got this guy over here that could go right there like that. Yeah, like that right there. Something like that. And then that would be a way to do it. But I don't know about that either. So what I've done is I went on to McMaster-Carr, and basically when you buy stuff from McMaster-Carr, you buy shipping and then they give you parts for free. So I bought some shipping from McMaster-Carr, and I requested that they give me a couple of these different hinge joints. Yeah, when I get all that stuff, I'll kind of run through it and show it to you and kind of give you an idea what I'm thinking with that. Come up with a little bit better solution than what we have right there. And then as for the top, made this here link the right length, and the right length in my mind anyway is that that and that is the same. So whenever this does its articulating thing, this is obviously going to be a fixed length here, and it's going to I can't explain what I'm talking about, but I think it should minimize the amount of travel required on that slip joint when this thing goes through its turns and when it articulates over bumps. I actually made a mock-up, sort of a model of how this thing will act when it is turning and going over bumps. It's at work right now, but I'll try and remember to bring it back home so I can shoot a video of it, show you how it kind of works. But it gave me a good idea of how this thing's going to act when it goes over hills, or goes over bumps. So what happens is whenever this turns, whenever it pivots around the center, since that top link is solid, it stays a fixed length, and what effectively happens is it makes the nose go down. I mean, it also makes the back go down, but there's not really much of the back to go down. So it makes the nose go down, and if you have it in a turn, and then you have a wheel or something go up over a bump, it makes the nose go down even more. So one modification I'm going to do, I'm going to adjust that top link so that the front attitude is a little bit high, sort of a high angle of attack, if you will. And then I'm also going to come in here, about right here, cut up to about right here, and then tilt this whole thing back. So instead of this being straight, it's going to be tilted back, because even with tires on there, I don't think I'm going to have a very good approach angle, and I do have some hills that I have to go up whenever I cut the grass, so I don't want the nose of this thing digging into the ground when I'm doing my lawn cutting. But yeah, so this is pretty cool. Give you a little demo of how this works. So I mean, it's easy to move. I mean, there's some rolling resistance going on here, but it works fine. So it works really good. I think it looks cool. What I'm hoping to do whenever this thing is finished, so this will be my chair, I want to have like an open area, maybe a piece of plexiglass or something, so that I can see the motor turn, because I'm a dork. All right, guys, that's what we did this weekend, so that's pretty cool. Yeah, appreciate you watching, and we'll see you next time.